Hello, Rahi. Well, that didn't help very much. Aseel. Go ahead and post the meeting just in case people don't have the link. Are you guys able to find my videos online on YouTube, by the way?
Yeah, I checked some of them out. I started the subnetting assignment. I know it's like very late into the game.
Yeah. So obviously you haven't taken exam 2 yet.
No, I haven't taken exam 2. I haven't done much of anything. I have been playing on my own server, so I don't know if I get extra points for open systems, but I haven't.
Not in this class. Not in this class.
No,
you will in that other class, but not this one.
But I got my VPN working, but since I'm like tunneling into one computer to another computer to another computer, I'll be working and then I'll get hit with a broken pipe, and then it's really frustrating.
Yeah, I know. Here's what I can do to help you, which is what I'll probably do is I'll set up a forward for you on one port.
All right.
Okay, like a SSH forward.
Okay.
And so what that means you can do is you can use PuTTY.
PuTTY to do a dynamic.
You can PuTTY to your server, and then you can go into PuTTY and say set up a dynamic localhost tunnel.
And then on my web browser, I'll set a proxy, and then from then I'll be able to access the Proxmox console.
Exactly. So you can basically, and you don't even need to do that, because you can just use the SSH tunnel and say, hey, if I go to port 8080, for example, or
and then point that to
3806, go to local port 8006 on 192.168, wherever it's living.
Yeah, that's how I have my own LAN set up, and I have like a little port knocking thing. So
you're using port knocking. Good. I'm glad you're using port knocking.
Well, I'm too paranoid to keep the port on my router open forever, because if someone accesses that, they have access to like everything. And then inside of my router is like SSH keys and all this stuff. So yeah, I set it to knock to open up my secure shell port. But yeah, I'm expanding my home lab because I don't have anything to do. I don't go to work.
Oh. So, you should come work with me for a while.
You need help?
Yeah, I sure do.
Yeah, you can put me to work.
Drowning is how good are you at SQL?
I can write some queries on Oracle or Microsoft.
It's MySQL. It's generic SQL on Linux servers. So it should be pretty easy stuff.
Yeah, at work it was mostly Oracle and doing PL/SQL, but I know MySQL.
Yeah, it's actually Maria SQL, but it's the same thing.
Okay. Yeah, I have.
Okay, guys. So welcome to 4477 MIS. Let's hit chapter 10 today. The internet. Let's talk about the internet today. Can you guys see my screen sharing? Oh, my computer's going slow because it's saving the previous video at the same time. Okay, so again, these PowerPoints are a little bit dated, so I'm going to fill in spaces and I'm going to go over to some different websites to show you guys some different things. Let me close some of these virtual windows. That's probably what's slowing me down. Remote viewing a bunch of crap. Give me a second, open that chat window back up. I see a couple people are typing. Oh, you're just typing in yes, okay. Where did it go? Give me just a second. I'm trying to find the thing I just downloaded. There it is. Chapter 10, the internet. Okay, so you guys are, everybody in here pretty much was born in the age of the internet. So a lot of you guys know a lot of this stuff already. So I'm going to skip over a little bit. I'm also going to skip over stuff that's not that important anymore. But the thing that you need to get out of this chapter that's important is who controls the internet, the governance of the internet, who has control, because there are some controls. There's several entities, of course, that participate. So we'll talk a little bit about the background of the internet and how some of that control developed. So the internet, and keep in mind that the internet is a very dynamic thing. You can't really draw a map of the internet. You know, you can Google for, I've seen several people try to Google for and show a map of the internet, but there really is no such thing as that. See if I can Google for one real quick and just, there's all different kinds of things that call themselves an internet map. They start to look like the COVID-19 map after a while, but and there's more than one internet, by the way. Keep that in mind too. There's the internet that we know of, which basically runs on port 80 and port 443. But then there's also a bunch of other private internets. There's the dark web. There's governmental networks, and they either run physically on separate networks or they run on separate ports, or they use different programs. They don't use your standard web browsers. They use enhanced web browsers, or they use something other than port 80 or port 443. So who's heard of the dark web?
I used to host a Tor node, but
Cool.
then, you know, I figured, what are people doing with this? So I turned it off.
So you used to, so everybody was downloading Kali Linux from you and hacking the ATM machines or whatever?
Yeah, I mean, it's hard to use it because all the addresses on the dark web, it's like a long hash. So
right, yeah. Instead of going to HTTP something, you're going to HTTP. Yeah, you're going to something that looks like that.
Yeah, pretty much.
.com or .something. So yeah, and it's because they're being hidden. So anyway, the web that you guys know and the web that I'm going to teach is the normal, usable public internet type web. Okay, so keep this in mind, first of all, the World Wide Web. And by the way, how many people have seen websites that say, go to my website at www.uh.edu? Most of the time, 99% of the time, guys, you can just go to the company's site, uh.edu, and it usually takes you to that correct location. Where'd my chat window go? Takes you to the correct location. This is kind of a throwback thing. So back in the old days, before the World Wide Web, so the www part is the GUI part of the internet. The internet itself is existed for many, many years. First of all, who knows what started the internet? What started the internet?
DARPANET.
Yeah, but what specific event? What event?
The Cold War.
Yeah, the Cold War started the internet, specifically Sputnik. I don't remember if I talked about this in the beginning of the semester, but you need to know a couple things because these will be questions on the test. What Sputnik was? Who can tell me other than people over 30 what Sputnik was? Any of you millennials or Gen Zers in here know what Sputnik was? Yes, Russian satellite. It was the first satellite, not just a Russian satellite. It was the first satellite that man launched into space. Now, what could Sputnik do? What was it?
They could spy on us.
Not even do that. We didn't know. We were in the middle of a Cold War with Russia. All we knew is that they launched a rocket and that they put something in space. All that Sputnik is, and by the way, anything that orbits the Earth is considered a satellite. So the moon is a satellite. This is called first artificial satellite that was launched. That's basically a basketball-sized satellite with 4 antennas sticking out of it. The only thing that it did was issue beeps. Just beep, beep, beep. We could send beeps to and from it. We could use it to transmit radio signals, but it didn't have any cameras on it, as far as we know. It probably didn't have any cameras on it. That wasn't advanced enough at the time. That wasn't the point of it. But we didn't know what it did. It scared us. And so the United States said, hey, we need to get all of our smartest people in the world together and basically win the space race. In other words, we need to launch our own satellites. And it was kind of a show of force and also a show of just in case we needed to put missiles up into space and shoot down satellites. Because they figured, well, if Russia can put a satellite in space for radio communications, they can also put a satellite in space and put nuclear missiles on it pointed at Washington and New York and all of our major cities. So that really scared us. So the internet was born out of this because of the need to get all of our scientists together in one room, which would not be a good idea, but get them all together and basically come up with the same ideas or come up with better ideas. So our answer, and the reason that we won the space race, USA won the quote unquote space race. We won because what other event that occurred in 1969. So Sputnik was 1957. What happened in 1969? JFK was the one that started it.
The moon landing?
Man on the moon. So because we were able to get to the moon first and claim it, the moon actually is USA territory, by the way. It's officially USA territory. So because we were able to get there first, we became dominant in that area. And so it was just basically a show of power. And eventually the Cold War went away. And now we're not really at war with Russia, although we have a lot of disagreements with them from time to time. But that happens all the time. The World Wide Web was born because we needed, not the World Wide, the internet was born because we needed to figure out a way to get all the scientists in the world talking to each other without bringing them together into one room. That's a dangerous thing to do. If you bring all the smartest people in the world together to dream up, how are we going to get to the moon? What technologies do we need to use? Well, this Sputnik thing, if it's got missiles on it, or if Russia launches another satellite with missiles on it, they can bomb that facility that has all the scientists in it. So we needed a way to remotely communicate. So remote communications, the thing we're doing right now, the Zoom meeting we're doing right now, started in 1957. That's how long we've had remote communications technology, almost as long as we've had computers. So this whole thing that we're doing with Zoom right now, it's not really new. The concept of it, not new at all. It's older than most of your parents. Okay, it's older than some of your grandparents. Been around a long, long time. Remote communications, or the real correct term for what we're doing right now, is called telecommunications. It's just that you guys assume that term means telephone, using your cell phone to call somebody. It just means communication over distance, as I mentioned in the first part of the chapter. So all these different scientists were working at different universities, different military installations. They all had, or most of them had, mainframe computers, and they had some sort of internal communications, an email or file sharing or whatever. And so basically we figured out how to use the telephone system to connect all these mainframes together with modems and share that email. And we had to develop protocols for sharing the information, and that's where email was born. So the first big usage of the internet was for email, also for file sharing, and eventually for live communication, but that came on a lot later. So I was born in a time where the internet existed, but it was not the World Wide Web. The www, that thing did not come along. uh.edu or www.uh.edu did not come along until about 1990. And I was actually in school at U of H at the time. And we had some of the first, we were one of the first nodes on the internet. Rice University was there first, and then we were close behind. We were using something before Chrome and before Internet Explorer called Gopher. Now, I'm not going to ask that question on the test, but you should probably go Google for Gopher Internet Browser and go see what that was, because it was not a hypertext thing at all. It was all text-based. But what it was basically doing was replacing libraries, replacing the need to have to read books, basically. So it's all very fascinating, at least to me, historically, very fascinating stuff. But I just want you to understand that the internet has been around for many, many years in some form or another since 1957. As Rahi mentioned, it started as a government organization. So the internet was started by
Man, this is not good.
an organization called DARPA.
I keep forgetting about this platform.
What's that? Who's talking? Turn off your mic unless you're talking to me.
Shout out to my friend Rob, who texted me.
He says, Joel,
Okay.
where are you, man?
Is that Joel talking? I'm going to mute you. Okay, Joel? Raise your hand if you want to talk. Okay, so DARPA. You do need to know who DARPA is, so you can simply Google a lot of these things. I'll go over that. So there's a lot of things that are not in the PowerPoint. So if you just were to go type in what is DARPA, it still exists. Okay, DARPA is a branch of the federal government, the United States federal government, called the Defense Advanced Research Projects Agency. They are the ones that look for little green men. There was another project other than the Internet Project, which is called Project Blue Book, which they were looking for aliens from another world. I don't think we've ever found any aliens from another world, and if we did find them, they've been dead for millions of years, or vice versa. We've been dead for millions of years. So one thing that DARPA did was develop the protocols and develop the communication, and all the money came from the Defense Advanced Research Projects Agency. So the internet was originally called the DARPANet. That's the original name of the internet, DARPANet. Move that thing out of my way. Something on my screen you guys can't see that's in my way. DARPANet. That was the original name of the internet. It was a military thing because of Sputnik. Eventually, and that was back in the late 50s, eventually, and the people that belonged to the DARPANet were military installations and universities. So it was mostly military and universities. And it was 99.99% of it was in the United States. The internet, as we know it, started in the USA. Eventually, we won the Cold War, and all of that went away, including all of the funding from DARPA. But all these universities that were connected together, like U of H, like Rice University, like MIT, like Berkeley, UC Berkeley, all these different universities realized, hey, there's value in staying connected. So let's carve out some of our budgets and let's continue to operate this network thing. so that we can send emails back and forth to each other, so that we can communicate, so that we can publish papers. So after the military dropped out, we took off the D and we called it the ARPANET. So when I was first starting at U of H in 1983, I got an email address. It was jake@129.7.1.7. That was my email address in 1983. I was on the ARPANET. There was maybe 30 or 40 total nodes on the entire internet in 1983. There weren't very many. It was just basically the universities that could afford and wanted to participate in this. So the early to mid 80s is really when the internet began to start, as you guys might know it, the underlying part of the internet. Eventually the internet added, there was a fellow named Al Gore. You guys know who Al Gore is? One of our former vice presidents who talks like this, because I think he's from, where is he from? South Carolina or something. So Al Gore was our former VP, and he helped put a bill in place that would fund what's called the information superhighway. That's how he used to say it. And he's kind of famous for saying because he ran for president, as you guys know, he was kind of famous for basically intimating that he invented the internet. Al Gore did not invent the internet. It was there long before he had that, long before he was a politician. But he helped make funding from the federal government, not the military part of the government, but the taxpayers part of the government, to fund the information superhighway, essentially to give money to the universities, such as University of Houston. And we helped develop protocols for the World Wide Web, such as HTTP, Hypertext Transfer or Transport Protocol. HTTP uses port 80, okay, keep that in mind. HTTPS, which is the secure version, uses port 443. Those are probably the two most commonly used ports. TCP, that's at layer 4, port numbers that are used so that we can identify segments and packets that are coming into our computers. Okay, so keep all of that in mind, that the internet started as a military deal. Eventually, the military went away from it and said, we're not going to fund this anymore because Russia's got a whole other boatload of problems with all the other little countries around them. Well, back then it was called the Soviet Union. And so we said, hey, let's keep going to the moon for a while. Let's keep doing some space stuff. Eventually that went away. And really the reason we never went back to the moon is we didn't need, it was very expensive to do, and we didn't need to do it anymore. There's not really much on the moon, as far as we know. Even still, it's kind of just a dead rock, as far as we know. Probably better to go to Mars than the moon. So let's get back into the official PowerPoint here. So internet providers, everybody here, including University of Houston, has one or more internet providers that you use to connect yourself to the internet. So the original connections and the original ISPs, there used to be many per city by the mid-90s. And some of you probably remember some of the original ones like AOL. Remember all those CDs, or maybe your parents remember this, they would just hand out CDs on the street corner or mail them to you, or you get them for free all the time. AOL CDs trying to get you online on their version of the internet. Then there was also US Videotel. There was a few others like that. Those are the two that come to mind that I remember. And they had their own little browser, but it was basically using the same technologies, but they were dial-up providers. You had a telephone and you had a modem, and you used dial-up to communicate to an ISP. So in Houston, at one point, there was probably 500 ISPs. Nowadays, there's about 5 ISPs that provide services to individuals and end users. The reason that most of these ISPs went away is because dial-up went away. We no longer use modems because that technology is so old. The fastest you could get the fastest download and upload speeds that you could get using dial-up, using your telephone and a modem. You guys remember that modem I brought to class that showed you that modem from War Games? That's the original modem I used to use. That was only 300 bits per second. So 52,000 bits per second, not a byte, but a bit, was the fastest that we could transmit data. That is painfully slow. That wouldn't be usable for today. So dial-up, which is dynamic, went away because of the invention of DSL and eventually DOCSIS and using cable modems and eventually wireless and Wi-Fi. Those things all kind of killed all the ISPs. So the only companies that really are ISPs now are the companies that have major infrastructure already in place that provides dedicated connections. Everybody these days is not using a dynamic connection unless you're using your cell phone, which is still a form of dedicated connection. Your cell phone is dedicated to be connected to Verizon or AT&T or Sprint, or actually, well, it's not Sprint anymore. What is that? Oh, my video's done. My video's done clean. So there's not very many ISPs anymore, but you're essentially dedicated to these different ISPs, and it's not easy to change them. You have to go change your phone. So the two prevailing ISPs in town for end users are Comcast and AT&T. In Dallas, it's Time Warner Communications or Time Warner Telecom. In other cities like Atlanta, it's Cox for cable modem service. It might be in some smaller towns. It used to be, they went out of business and got bought by another company. Windstream. Anybody ever heard of Windstream? They're kind of dead, mostly because they were a terribly run company. And now they're in bankruptcy, and their new version of that is called Kinetic. But don't sign up for that, guys. If anybody's in the Sugar Land, Stafford area, or up in North Houston, don't sign up for Windstream. They suck. Some of you are in some neighborhoods where In Touch serves, Frontier. So these are all names of ISPs. Does anybody have any other ISP that you know of that you use? If you live in an apartment complex, you may use some of these, or if you live in a condo, it may be getting supplied to you and you don't know who gives you the internet. Does anybody have any other names that they know of? No, yes. Are these all familiar to you guys, the ones I'm mentioning now?
Yeah, yeah.
Okay. Verizon, yeah, there's another one called Fios. Now there's some other internet providers as well. These are all terrestrial based. And then there's also HughesNet and DirecTV and Dish Network. They provide satellite internet communication. By the way, satellite internet communication for individuals sucks bad. Don't ever sign up for satellite communication unless it's your only choice. You're in El Campo, Texas, or El Nowhere, Texas, or El Nowhere, Kansas, or you're not anywhere near any sort of infrastructure. Wired is always going to be better than wireless, or the satellite, I should say. The next best thing to use would be to use wireless on cellular. So that's kind of a last resort to use these. Anyway, internet providers, there are different tiers of internet providers. Most of you, and the reason I mentioned all those internet providers earlier is because the lines kind of blur now between some of these different tiers. Like, for example, AT&T, which is probably the biggest ISP for both businesses and individuals in the country, sadly. The AT&T of today, by the way, is actually Southwestern Bell, based out of San Antonio. Their customer service is terrible. They're too big. They try to be too many things to too many people. They're kind of like Microsoft or Amazon even, which some people argue is not good. But so AT&T doesn't really fit into these, but several of the others do. So a tier T provider is a local provider. I show a map here. So in this map, this is a little sample map here. Each one of these little tier 3 circles here is a local company like In Touch or Phonoscope or PS Lightwave, they call it, or Frontier Communications. And they may have multiple POPs or points of presence or not inter-exchange points, but multiple points of presence in certain areas of the country. And that's because 99% of ISPs now are dedicated services. You literally have a cable coming from your home or your business to this provider. There's not really dial-up anymore, at least not in this country. There is some wireless. There's some fixed wireless, they call it. And then the extraterrestrial wireless, which is the satellite stuff. These tier 3 providers then communicate in their areas with a tier 2 provider, which doesn't deal with end users. They don't deal with individuals. They don't deal with customers. Examples of a tier 2 provider might be like level 3. That's the biggest one I can think of. Level 3 does not sell services directly to businesses. They sell services to other communication providers, such as Comcast, such as Frontier, such as me. I'm a excuse me, I'm a customer of level 3. I have very fast internet, not here at my home, at my data center. In my home here, I use Comcast because it's the cheapest thing. So, what's the other name? CenturyTel or Century Communications. They also are a tier 2 provider. And then you have a few large tier 1 providers such as AT&T. And then actually since, the way that you know that whether they're tier 3, 2, or 1 is who their primary customers are and what they cover, what areas of the globe they cover. So in the extraterrestrial, that doesn't mean aliens, by the way, but in the extraterrestrial market, HughesNet, DirecTV, and Dish, which have their own satellites, they can literally reach every point on the earth. So they are a tier 1 provider, but they also do sell services directly to end users. But they provide bandwidth to AT&T or other organizations that don't have satellites because there's certain parts of the world you just can't get to easily with a cable. It's much easier to get to somebody with a satellite because a lot of them are already there. There are other companies that just do nothing but launch satellites, like RCA, for example. You know, the RCA used to be a big TV company and a broadcasting company. They pretty much just do satellites now, and they rent their satellite space and their radio waves to other providers such as Dish and DirecTV. And I've talked about geosynchronous Earth orbit satellites. So let me back up for a minute here. So tier 1 are national, tier 2 are regional, like within a certain state or within a certain market. And then tier 3 are the people that deal with the end users. And I'm not talking about consumer versus business. I'm talking about people whose primary connection focus is the end user, the customer, not another communication company. The way these companies make money is tier 3 providers charge you, the end user, tier 2 providers charge tier 3 providers, and then tier 1 providers charge tier 2 providers. It's just a hierarchy. And then tier 1 providers come together, and it shows this on the map here. There are certain points throughout the country called inter-exchange points, and certain points throughout the world are called IXPs, inter-exchange points. There are only a few inter-exchange points in the United States. They are in central locations. So you could actually Google for that. USA IXPs. And we should be able to find a map of the major US IXPs. So there's not a lot of them here. That's a relatively recent map of the IXPs, excuse me, not ISPs, but IXPs. This is where the major tier 1 providers come together in a central location and they pass off traffic to each other. They'll rent some space in a co-located facility. And you'll notice, by the way, Houston is not an IXP. Isn't that interesting? Why is Houston not an IXP?
We're susceptible to hurricanes.
Yeah, there's a lot of reasons why we're not, but Dallas was a more centralized area. The electricity's cheaper there. They're not on the coast. So they're more of a centralized area. So if you were to be, if you would want to be a tier 1 provider, you would want to be in Dallas, not Houston. Now, we do have some sub IXPs in Houston because we are such a large market, but those are not official. So, for example, Sprint and AT&T might decide, hey, we have a lot of traffic that we send back and forth, and you've got some customers and we've got some customers. Let's connect together in what's called a peering agreement. Because we are peers, we are equal to each other. Peering means you are equal to each other and you share your bandwidth, or you share your data, I should say. You build a bridge from one provider to the other, but you don't charge each other because you're basically equal to each other. AT&T and Verizon might say, okay, I've got 1 million customers, you've got 1 million customers. It benefits us to give you access to the entire internet, not just our internet. So let's come together at these interexchange points and not charge each other. There might be some smaller tier 2 and tier 3 providers also at the interexchange points, but they have to pay the tier 1 providers that are peering with each other money to get their data up into the tier 1, and then the tier 1 providers share data with each other. So again, the maps they're not super big. Here's a global map of interexchange points around the world. And if you were to zoom in on that, there's not a lot of spots. You could almost say that is a map of the internet. It's not showing the connecting lines, but that's basically a map of the public internet as it was. This is put out by an organization called the Internet Society, which is a big group of engineers and people that choose to belong to that for the betterment of the internet. Okay, let's see. So that's kind of like what this map is describing, the interexchange points. ISPs apply for what's called an ASN, an autonomous system number, which is a block of IP addresses. University of Houston has an autonomous system number. So if you were to go, for example, to Aaron.net, and you do need to know who Aaron is. They are the American Registry for Internet Numbers. They used to be the exclusive coordinator of who gets IP version 4 internet numbers in the world. They no longer are. As of about 2 years ago, they've had to share that with the rest of the world. But you can use this. Let's say somebody's hacking you, or let's say you've got a public IP address and you want to see who owns that IP address. So if we were at U of H, we would be getting IP addresses of 129.7.something.something. And I'm talking about the public address, not private. So if I were to just search up that number, for example, which is a number that used to be my email address, it will tell me that that IP address belongs to this net block, known as the 129.7.everything.everything net block. That's the network range, 129.7.0.0 all the way through 255.255. That's a Class B subnet. Here's the CIDR notation, which is what you're doing in your subnetting right now. The official name of this is called UH.net. That kind of implies who's this net block belong to? It's University of Houston. It is a directly assigned net block. It's a big block of numbers, but the reason we have that big block is 1, we are a university. 2, we are a large university. And 3, we were one of the first nodes on the internet. We were like node number 23 or something. We were very early on. The original registration date was June of 1987. Now, we have been on the internet actually quite a bit longer than that, but Aaron didn't exist before then. We didn't register numbers before then. It was small enough to where it was just kind of an agreement. Okay, Berkeley, you use everything from 1 to 10, and MIT use everything from 11 to 20, and then U of H use everything from 21 to 29. It was just an internal agreement, but at some point, it had to start getting coordinated, and that's what all these entities do. Aaron, Network Solutions originally was the coordinator for names. Somebody has to be coordinating this information. And I've invited you to look at these before, so I want everybody, you don't have to do this now, but at some point, everybody needs to go to IPChicken or IPmonkey.com, get what your public IP address is, and copy and paste that into Aaron and then see who owns your net block. You scroll down to the very bottom, because it may be a very large net block. Whatever the bottom entry is, that is who your provider is, probably a tier 3 provider. There might be other stuff on top of that that indicates there's a tier 2 and a tier 1 provider involved. So in our case, we're considered a tier 1 provider, almost, not really, but we are about as high as you can get in terms of having our own net block. In other words, we can make the rules. So this is called an ASN. We have an autonomous system number. In other words, that range, no matter what internet provider we choose to use for our communication, because we're not a communication company, they have to use those numbers that we give them. So if we were to go to Comcast and say, hey, we want an internet connection to the internet, Comcast will say, okay. And then we tell them, but you're not going to give us IP addresses. We already have our own. We'll tell you what our IP addresses are. That's called direct assignment. It's an autonomous system number block. The only organizations that have autonomous system number blocks are large organizations. I used to have one, but I'm not large enough, so it got taken away from me. It was originally called, it was one of the AMS blocks. So I had a company called Advanced Medical Systems. I don't think I remember it anymore, but. Or let's see if I Google for my name. I should pop up in here somewhere. Yeah, see, so I've been a member of Aaron and been doing this for many, many years. And like I said, I used to have an autonomous system number block. So I had a specific block of IP addresses that no matter what internet provider I used, I could tell them what my IP addresses are. Gosh, this is bringing back memories. Oh no, that's not me. That's a different Jake. I promise you I'm in there somewhere. So go look at that stuff up. Interesting stuff. Now we have, like I said, only large entities have these. If you're a small company or individual, you don't need an autonomous system number block. But if you're a large company like Amazon.com, who's not in a communications company, but they're large and they have many installations, they will apply for it, and they have their own autonomous system number block. We should be able to look them up. And we can get, Aaron's not really designed to look up domain names, they're designed to look up IP addresses. So what you can do is you could go ping Amazon.com, see what one of their IP addresses is, and then go plug that in there and see what it shows you. So I'm not going to do that because I don't get bogged down on this, but ASNs for large organizations or for communications companies, the reason you apply for an ASN is so that you can go and use any internet provider and provide your static IP addresses. It's like keeping your telephone number with a cell phone. So I already talked about peering. ISPs at the same level peer with each other, don't charge each other. ISPs at a lower level have to pay the upper level. So I pay an upper level ISP because I don't have POPs in every city in the world or every city in the country. I have a POP in Houston only. So I can provide internet services to some companies in Houston that choose to go to me, although I don't really do that anymore. I used to. So there's the map of the original United States inter-exchange point locations. There's actually right here, this is semi-inaccurate. Las Vegas is one of the largest inter-exchange points now because it's also a location for co-location of data, not just of communications, but of data, co-location facilities. ISP backbones. Remember the OC service that we talked about in the last class? Optical character fiber, OC 192. So the internet, the tier 1 providers communicate with each other with 10 gigabit per second, 40 gigabit per second, 100 gigabit per second. I'm actually installing a network right now with 40 gigabit per second network cards, by the way, as an experiment. But 160 gigabit actually goes even beyond that. So internet peak traffic, like I said, these notes are a little bit old, but by 2018, peak traffic per second that's traveling through the internet was estimated to reach 1 petabit. So what's a petabit?
1,000 terabytes.
I'm not going to ask that question on a test, but you can Google for that. You get terabyte. After terabyte is petabyte, and then exabyte. Eventually, you get to a Google byte, which is a 1. Well, that's where Google gets their name, which is a 1 with 100 zeros after it, or a 1 with 99 zeros after it. It's a 100-digit number. It's a big ass number. So, you know, like 20 years from now, you'll be able to go down to Walmart and buy or go to Amazon.com and buy a 1 Google byte drive. But until then, we're still in the terabyte / petabyte range / exabyte range. So I mentioned this term already in last class as well. In order for a customer to get service from an internet provider, they have to have what's called a POP, or a point of presence. Usually it's written with a small o, a big P, small o, another big P. Point of presence, not to be confused with the post office protocol, which is used for email, which is kind of dead. We don't really use POP for email anymore. We use something called IMAP. The POP connects to the rest of the ISP's network. Authentication is performed at the POP. So you guys all are connected with some sort of connection back to a point of presence. It's either a little box at the end of the street, or maybe it's a big box. And also, this is another thing that I invite you guys to do. For those of you that live in residential neighborhoods, walk around your neighborhood, staying 6 feet away from everybody next time you're out and about because you're going stir crazy, and see if you can identify some of the local equipment that is in your neighborhood that provides service to you. Sometimes it's just a little bump in the ground, but a lot of times it is it's a box. Like Comcast has boxes all over the city that provide services to a neighborhood. A neighborhood box. I'm trying to find one real quick. You'll see these little stumps here. This is with the lid off of one of them. You might see these little boxes. You might see these little things. That's a transformer. That's a power transformer. That's AT&T's piece of crap there. That's Comcast's better crap there. So you'll see things like this. With respect to Comcast, there's like one of these every 4 yards. Not 4 yards of distance, but 4 houses. So does anybody know, you have one of these in your backyard or your front yard that you know of? One of these little boxes right down at the end of the street? Take a look at it. See if you can get into it. Probably can't. It's not going to hurt you as long as it doesn't say danger electricity. See if you can pull the top off of it just to see what's in it. A lot of times the workers don't lock them back properly. And you can take the top off and just look and see physically the cables that are in there. Each one of these, there's a big thick cable coming to this, and then each one of these little taps feeds the 4 or 6 houses in the immediate area. This is what most residential and business infrastructure looks like. Most of it's in the ground. A lot of it's still on the AT&T still has a lot of their stuff on the telephone poles, which is not a good place to put wiring, but everything that Comcast now does is all in the ground. They will not put stuff in the air anymore because they learned their lesson, or they've learned their lessons that putting stuff on telephone poles, first of all, you got to pay whoever owns the telephone pole, which is usually Southwestern Bell, aka AT&T, and they charge a lot of money. The cities have to allow somebody who's registered as a internet provider or a cable provider the ability to put cables into the ground. They can charge them for it, but they have to allow it. They can sell them permits, but they have to allow it. The internet is officially a utility now. Some organizations use WAN technologies to connect to their ISPs, broadband technologies. So DSL, I've mentioned that a couple of times. DSL is pretty much dead, but it still exists in some areas of the country. It's a legacy service. The fastest that you can get on residential DSL is only about 20 megabits per second down and only 1 megabit per second up. For business DSL, the fastest you can get that anybody sells is about 100 megabits per second. So it's inferior. It's older technology. It's been around since the mid-90s. Cable service is probably the most common for businesses, small businesses, and home internet. The next most common these days is probably what's not on this list, which is cellular. A lot of you guys don't have internet services that are hardwired. They're cellular. You're using your cellular modem or your cellular phone as a hotspot. Is anybody using a hotspot right now, guys? Anybody using their cell phone to access the internet right now? Or have you used it? It sometimes works, sometimes doesn't work that well. Then there's fiber to the home or fiber to the curb. So you'll see these terms FTTH or FTTC. We're in newer neighborhoods. So KALED, you're using your cellular right now for your mobile hotspot? Or you pronounce it KALED or KALED? Okay, and you're doing that because you don't have dedicated service, or it's just too expensive, or it's broken right now? I'm just curious why you can turn on your mic if you want, or type, I don't care. But it would be good to share it with the rest of the class just so they get a more real world example of this. There used to be something called WiMAX. There was a company called your Wi-Fi's went down or is not working. Okay. So there used to be this called WiMAX. It operated in the 2.5 gigahertz range. It was put out by a company. And the only reason I mention it is because it just shows you the power of some of these organizations that provide internet services. WiMAX. So there was a Clear Communications. Got permission from the federal government to use the 2.5 gigahertz range for wireless internet that could go between 8 and 10 miles. This is before the cellular providers, or was in competition with the cellular providers. It's called WiMAX. They charged a flat rate. Clear Communications. These things started popping up. Maybe some of you remember these things. They popped up everywhere, all over Houston, all over Dallas, all over LA. Little kiosks everywhere to sell these modems. You could get 10 to 12 megabits down for $50 a month flat rate, which was a really good deal. And it was wireless. I used to drive around with one in my truck and provided Wi-Fi to whoever, internet to whoever wanted internet with it. Sprint said, hey, that's a really cool thing. So Sprint bought WiMAX, or bought the technology and bought the company, the Sprint WiMAX network. 3 months later, they killed it. And they paid $4 billion to buy it, $4.4 billion to buy it, and then they killed it. They said, go away. We don't want WiMAX anymore. They claimed that, oh, it was inferior technology and they had better technology. That's not actually true. The reason they got rid of WiMAX is because it was also in competition with them bringing out their 4G LTE, which was a cellular standard. And at the time, I don't know if anybody remembers this, but a few years ago, you did not have unlimited data and voice packages. You had to pay for your usage. You had to pay per minute for your usage, or per gigabit. And some of you still have to pay for your internet usage unless you're using it just on your phone. But usually these days they don't make you pay extra for your usage. They do this other thing called throttling. Anybody ever experienced throttling? You get a certain amount of megabits per month, and it's usually in the fine print when you sign a contract with Verizon or AT&T or Sprint. Oh, by the way, I forgot to mention this. Guess what happened officially today? Sprint and Verizon officially joined, and they're now one. Or wait a minute, is it Sprint, Verizon, or Sprint and T-Mobile?
T-Mobile and Sprint.
Yeah, excuse me, T-Mobile. T-Mobile and Sprint, number 3 and 4 in the market, merged to become a larger number 3. So they're still number 3, but T-Mobile and Sprint merged with each other. Sprint's been losing money. But anyway, Sprint bought WiMAX and killed it, even though it was better technology. It really pissed me off. WiMAX still exists in other countries, but the 2.5 megahertz range, gigahertz range, not used in this country. So I may ask a question about WiMAX on the test, but only in terms of what happened to WiMAX and why aren't we using that? It's dead. And that's because we've got 4G LTE and now the 5G. So, like I said, in the fine print of your agreements that you sign when you get cellular services, oh, you're getting fast throughput. And like KALED, what kind of throughput do you get on your Wi-Fi? When you go to speedtest.net, for example, you might get really good throughput at the beginning of your billing cycle. But try this, towards the end of your billing cycle, try to go to speedtest.net on your Wi-Fi, not your Wi-Fi, your cellular, and do the test there. You're probably getting much lower speeds, and that's because everybody has to deal with throttling. And that's where the internet service providers give you a certain amount of megabits or gigabits or terabits per month. And as soon as you hit that threshold, they throttle your traffic way down. And that's because they have limited bandwidth. They're having to pay upstream providers, and they pay them based on the amount of bits going through it's not always fixed rate. They pay based on usage. Okay, getting back to this. Okay, so the point-to-point, as I mentioned before in the previous class, that little cable that connects you to your internet provider, we either call that the local loop or we call it the last mile. So make sure you know what that term means, local loop and last mile. You should know that also for test 2 as well. Before you take, if you haven't taken exam 2 already. Asymmetrical, and we'll talk about asymmetrical in a minute too. That's not always just 1 mile. It's usually anywhere from 500 feet to 5 to 6 miles for wired, and for wireless it can be 10 to 12 miles. Rarely much further than that, unless you're using satellite, then it's 22,000 miles. I guess I'll mention asymmetrical now. So most of you are using asymmetrical. Internet, which gets businesses all the time. They go and they get internet speed from Comcast or AT&T. They say, oh, we're going to give you 150 meg speed. Oh, that's so fast. 150, and they say megs. First of all, megabyte is not the same thing as megabit. Speeds are sold in megabits, and you need 8 bits to make a byte approximately, actually a little bit more than that. So 150 megabits is really only 15. We just usually round it up to 10. 15 megabytes or 15 million bytes per second. Keep that in mind. Also, that's almost always symmetrical. That's your download speed. Your upload speed is usually 1/10 of that. So like Comcast, for example, I have Comcast 150 at my house. My upload speed is 15 megabit, which is actually pretty fast, but that's because I pay a little more for it. Most of you probably are using something that's probably like 60 megs down by maybe 5 megabits up. And that's okay for most of you. Why is asymmetrical okay for most of you? That's because most of, 99% of what you're doing is downloading. You're bringing stuff out of the cloud down to you. You don't really have a lot of stuff at your home. But where it's a problem is if you do have a lot of stuff on a home computer or a home server or a small business server, a lot of data that needs to get backed up into the cloud, or needs to get up into the cloud or get onto the internet, your slow speed uploading can really kill you. Also, bear in mind that most residential internet providers block port 25, which is the SMTP email port, so you can't run email servers at home on a residential business. I learned that the hard way. I set up a little home server to run one of my home domains and spent a lot of time on it. Could never get it working, and then I called Comcast and I said, oh, well, that's a residential account. We block port 25. You'll have to upgrade to a business account and pay more money per month, which I did. The point is asymmetrical is usually only okay. It usually is okay these days. Let's see, 180 down and 6 up. Yeah, that's pretty pathetic. But if you don't have much at your home, that's okay. It's equivalent in the real world of having a road that goes somewhere and there's 10 lanes that go from somewhere to you and only 1 lane that goes from you to somewhere else. one lane back the other direction, which is, of course, if you have a lot of stuff that needs to go up that road, you're going to have to line it all up and it's going to be slow. It's going to be traffic jams. So asymmetrical versus symmetrical internet service. Symmetrical always costs more. Most DSL is symmetrical. So when DSL came out, the residential DSL was typically called ADSL, asymmetrical. The A stands for asymmetrical because it was much faster down than it was up. Symmetrical DSL cost a lot more money. You cannot get cable service that's not asymmetrical. If you want symmetrical service, in other words, 10 down and 10 up, or 100 down and 100 up, you got to get fiber service or dedicated services where they're giving you that, and it's going to cost much, much more. Much more money. The equipment, the generic term for the equipment that sits at your home is called customer premises equipment. That could be a modem, that could be a firewall, that could be a gateway, that could be your cellular phone. But the generic term for it is called customer premises equipment. The local loop or the last mile is a circuit from you to your ISP. The MDF is another name for the point of presence, or it's the main distribution facility. It depends on your technology. Gotta watch the time here. Comcast has one main distribution facility in Houston and several little points of pop all throughout the city. Their main distribution facility is off Tidwell in Northwest Houston. AT&T has a bunch of main distribution facilities all over town called COs, central offices. And so I'm going to give you a little bit of history. I don't have a lot of time for this, but AT&T, CO, central office. Every major part of the city has a CO in it. About every 12 miles or so, you will see a CO. These are two-story brick buildings with a Bell logo on it, maybe one door in it, and nobody there. And that's because it's just a bunch of switching equipment in there in the central office. Those central offices originally were associated with one specific prefix of a telephone number. My telephone number when I was growing up in Houston was 781-1139. That was my first telephone number that I remember as a kid. We had an area code, but we didn't have to use the area codes because Houston had one area code. It was the 713 area code. So all of that was Houston. And then within Houston, there was multiple COs, and a prefix or part of the prefix, the 78 prefix, part of your number was associated with a certain CO. There are letters on your keypad of your phone, right? What do you think those letters are for? Is it so you guys can send texts from your phone? They're there because originally the phone company didn't believe that people could remember 7-digit numbers easily. So the associated letters with the numbers. So the 2, for example, has ABC on it. So the 78, my original telephone number wasn't really that. It was Sunset 1-1139. Oh, excuse me. It wasn't Sunset. Excuse me. It was Prescott. Prescott 1-1139. Sunset was on the other side of the road. There's one in A-Leaf, which is Buffalo. So if you look at the letters, P and R, the P is on the 7 key, and the R is, oh, excuse me, that's not right either. It was Sunset. Excuse me, I apologize. Later on, I moved into the Prescott CO area, which is over in the Sharpstown-ish area, the real ghetto part of Sharpstown, and it was the Prescott CO because my telephone number changed to a 774. So Sunset 1-1139, there's a bunch of COs all over town. So I challenge you guys, this is not homework, but I challenge you guys to see if you can find a CO in town and see geographically where it is, because they're all named different things that we remember. There's Sunset, Buffalo, Prescott, Oxford, which is up in the Heights area, semi-interesting stuff. But basically those COs have been turned into the points of presence for DSL and internet service providers now. So that's your CO. There's one over off 288, by the way, near Old Spanish Trail. And these things are dungeons, literally, by the way, these days. Like I went into a Windstream, I called it a dungeon, a Windstream CO recently before they tore it down. And it was literally a dungeon. It was nasty. The switching equipment was 30 or 40 years old. The ceilings were leaking. And they were telling me, oh, well, we're going to convert this into a co-location, or you can co-locate your servers in here. And I'm like, hell no, this place is a concrete dungeon, and there's barely any air conditioning in here. So anyway, there's ADSL, VDSL. Most of us in Houston are lucky enough to have coax. The actual term for the protocol that we're using is hybrid fiber coax, HFC. And that's because most of these boxes at the end of the streets in your neighborhoods have a fiber cable going to them, not a coax cable, a fiber cable. And then that fiber cable breaks out in switching equipment to several coax copper cables that run to each of the homes. And that's for several reasons. One, because all the coax cable was already put in place 25 years ago when Time Warner was here running a bunch of cable to the houses. Any new neighborhoods that are going in, like where my dad lives out in Richmond, he lives in the Del Webb Sweetgrass retirement neighborhood, they have fiber. My dad actually has better internet than me just because he's in a newer neighborhood. Anybody else in here have fiber, by the way? Fiber to the curb or fiber to the home, FTTH? AT&T, by the way. How many people have seen those ridiculously stupid AT&T commercials? Well, you got cable, you're nasty because we don't talk cable here, we're all fiber. Well, that's a load of crap, because AT&T's fiber is available in about 5% of the city of Houston. And it's not much better in most major metropolitan areas. They just don't really have the coverage, but it's because it's expensive. Yeah, they only have it in new areas or high rises or in the middle of downtown. And that's because it's super duper expensive to put in. So they're only going to put it in high density areas. They're only going to put it in new areas, or they're going to only put it in areas where there's a lot of high demand. So they're heavily advertising it to try to get the demand, to try to get you to sign up. I signed up for it for one of my locations. It literally took 9 months for them to finally drop it in place, which was, and I prepaid like $1,000 for installation. Had to sit there for 9 months for them to install it. So that's the way it is in Houston. Might be different in Dallas, might be different in LA, might be different in other areas. But interestingly, it's usually the more rural / newer areas that get the newer technologies, because there's not old technology there to deal with. They will also tell you, AT&T will also tell you that the fiber is dedicated and coax is shared. That's a lot of bullshit too, because it's dedicated from you to the central office, but all the websites that you want to access are not in the central office. They're on the internet somewhere. So at some point, your traffic is getting on a big freeway, just like everybody else's traffic in Houston, and going off onto the internet. So it's just a matter of where the branching is. That's all that is. It's mostly a lot of marketing bullshit. Excuse my language, but I'm using that on purpose because I'm trying to hammer that point home. Cable uses this layer 1 and 2. It's a protocol suite called DOCSIS. It's similar to Ethernet. You have a cable modem. Now, Comcast, if you buy the service from them, they typically supply you with a gateway, but they charge you. They charge like 12, 13, 14 bucks a month. You can go out and buy your own cable modem for 50 bucks, which I did, and then get your own gateway device that connects to that and save the 12, 13 bucks a month. Plus you have control over it. This is a really sneaky thing that Comcast did. Yeah, Comcast supposedly offers free Wi-Fi all over town, or Xfinity, I should say. Xfinity is the consumer version of Comcast. It's the same thing. It's just like AT&T and Uverse. It's the same thing. It's just all about marketing. They provide free Wi-Fi, supposedly. If you have Xfinity cellular service, for example, you can get on their Wi-Fi anywhere. That's because anybody that rents for 12 bucks a month, or in cases of businesses, 16 bucks a month, the business modem, the cable modem. Anybody in here have a cable modem from Comcast or Xfinity? That thing is also providing guest Wi-Fi to everybody around you, whether you want to or not. You can call them and request to have it turned off, but most customers, especially most residential customers, 99.999% of residential customers, don't know crap about what they got in their house. They just know they got internet. They're sharing their bandwidth to give Comcast a big footprint in town. So it's a little sneaky. They'll tell you about it if you ask them, or it's in the fine print at the bottom of a web page, but it's a little sneaky. So you might want to not share your bandwidth. They claim that it's not your bandwidth, it's theirs, and they're only guaranteeing a certain maximum throughput. But whenever I have my friends set up their internet at home, I say, go out and get your own cable modem, because they can't do it with your own cable modem. Or if you want to use their cable modem or their gateway, that's fine. Just call them up and say, please disable the Xfinity shared guest Wi-Fi off my cable modem. Keep that in mind, guys. Cable modem server. This basically looks just like that. It's just a matter of where the split happens. That's all that is going on. And then fiber to the home, setup basically the same. You have to have fiber optic service. It's usually more expensive. And then WiMAX, I'm just going to kind of skip over that because it's dead. It was an Ethernet standard 802.16, just like 802.11 was a wireless standard, but again, it's dead. Look at the maximum theoretical range, 30 miles. I mean, it was good stuff. I took one of my WiMAX routers out to my friend's property in Simonton, and then set up a big tall antenna that pointed back into Houston. And I was getting, not great, but I was getting internet service 30 miles away in the country. And he loved it because it was much faster than the HughesNet satellite service that he was getting out there, which the satellite service, it's not very fast. You have to pay for your data. You get maybe 10 gig, maybe 1 gig per month, and you got to pay for anything over that. And then the upload speed is ridiculously slow, and the latency is ridiculously slow. You cannot play Fortnite on satellite internet. The only thing satellite internet's pretty much good for is Netflix. That's all it's good for. High latency, LTE. Skipping that stuff. Okay, this is what I want to end the class with. Internet governance. Who runs the internet? You need to know for the purposes of test 3, exam 3, which will be available on the official last day of class. I need to look and see now what our official last day of class is. The Internet Society. The Internet Society is made up of these subcommittees. The Internet Architecture Board, the Internet Engineering Task Force, the Internet Engineering Steering Group, the Internet Research Task Force. Each one of these committees is responsible for a particular part of the internet. Some of them are responsible for protocols. Some of them are responsible for how IP addresses are assigned. Some of them are responsible for how names are assigned. Some of them are responsible for domain disputing. There is an entity, by the way, out of all of these, there's ICANN, Internet Corporation for Assigned Names and Numbers. They were the ones that originally handed out, it's not international. These were all, most of them were originally USA based. The International Telecommunication Union is international. Most of them are now international, but there's one organization that is the most powerful organization, in my opinion, in the world, which governs the internet. Nobody really governs the internet, but this is the closest you can get. So you need to pay attention here. It's called WIPO. Anybody ever heard of WIPO? Let me bring that up. Who is the WIPO? If you go to wipo.org, they're based in Geneva, Switzerland, by the way. It stands for the World Intellectual Property Organization. They're in Geneva because Switzerland is, quote unquote, a neutral country. That's why they decided to put it there. And basically, their primary job is domain name disputes. That's what they deal with. So there was a famous case a while back where Domino's Pizza, I believe it was Domino's, if I'm mistaken, I apologize, but there was a major pizza chain that had registered pizza.com, or they missed registering pizza.com, and a guy like you or me registered pizza.com and then called up Domino's, called up Pizza Hut, says, hey, I'll sell you the domain name pizza.com for $7 million. Let's see who owns pizza.com now. Everyone loves pizza. Okay, so I don't know who that is, but they're pretty freaking lucky that they got pizza.com, aren't they? So what the WIPO does, and there was not much governance back then. In other words, if I was a major company like major retail company like Discount Tire, and I have a discounttire.com, if I forgot to pay my bill for my internet name, and my name went up on the chopping block, basically, anybody that wanted to could grab it, pay $10 a year or whatever it was, originally $75 a year, and grab it. And so a lot of people were doing what was called domain sniping, where they were grabbing a domain the moment it became unavailable or expired, and then calling the previous company back and holding it ransom, saying, hey, Domino's, or hey, Discount Tire, or hey, IBM, or whoever, something like that. You got to pay me a crap ton of money before I give you this domain name back. Well, eventually this became a big problem. So, and the United States courts and the different courts of the different countries didn't want to deal with it because, of course, laws are different in every country. This is a civil case. It's not really a criminal case, but it's a civil case. You know, it's a defamation case, or it's a improper business practice case or whatever. So the WIPO was born to deal with issues like that. And I'll give you a quick example of the way I found out about WIPO. I didn't even know they existed until I kept getting these emails about a website that I registered called Collins.com. My son's name is Colin. When he was 4 years old, and I expected he'd be like this super hacker like I was or whatever, so I registered Collins.com, Collins.net, Collins.org. When he was 4 years old, and I said, hey, Colin, I registered these names for you in case you ever want to use them someday. He's like, oh, okay, Dad, whatever. He's 27 now. He doesn't use them or care about them. But I kept getting these emails. First of all, I would get an email from a Turkish company saying, hey, we want to buy your name, Collins.com, your domain name. We'll give you $100 for it. I'm like, no. Then I get another offer. Hey, we'll give you $500 for it. But it was always from either an AOL account or Gmail account. And when I asked them what they did, they say, oh, we're just a very small company in Turkey. We sell shoes or whatever. So I kind of ignored it. But then, and then they started getting really aggressive. And so I looked up Collins.com. Well, the Collins company in Turkey is kind of like the Levi's of Turkey. The name of the company is called Aeroglue. And at the time, I don't think I'm spelling, oh, there it is, Aeroglue Turkey. At the time, they were worth billions of dollars. Like I said, they're like they make everything in Turkey. They make jeans, they make shoes, they make industrial equipment, as you can see. They make whatever you want to buy. And one of their popular brand names is the Collins jeans. They're not in United States yet, supposedly. But they tried to register. So supposedly they're just in the Dominican Republic. Like I said, they're the Levi's. So they filed a claim with WIPO saying, hey, this guy, Jake Messenger, registered this domain name and he's squatting it. He's domain squatting it. And he won't let us use it. And we have the legal right to use it because we're the Collins Jeans Company. So I got this email from the WIPO saying, hey, we've got a dispute. You need to deal with it. And I didn't deal with it, kind of ignored it. And then I got another email. And so eventually I called up my internet provider and said, hey, I'm getting these emails from wipo.org saying that they're going to take my collins.com domain name away from me if I don't do anything. Is that legit? And they said, oh, hell yeah, that's legit. You need to deal with that. So I had to go get an account on wipo.org. It was free. Read what their dispute was. And they had to prove 2 of 3 things. They had to either prove that I registered the domain name specifically to keep them from registering it, Or I registered the domain name and I was disparaging the company. In other words, you could go to collins.com and it would say, yeah, Collins Jeans sucks and that company sucks and everybody from Turkey is a criminal or whatever, something like that. I don't believe that. One of my best employees I ever had was from Turkey. Or prove that I was not using it, that it was just sitting there, collins.com, and I had no use of it. Well, I wasn't really using it. I was just squatting on it. But I registered the domain name long before Collins Jeans existed. Now, the company Aeroglue claims, oh, we existed first. And that's because, yes, they registered their company name in Turkey 1 year before I registered that name when they were literally just one employee. So I had to answer that. It was kind of a long process. But the point was, if I had not answered that, and this is why they're the most important organization or the most powerful internet-based organization in the world. If I had not answered that claim and they were able to rule, and the way WIPO works is there's literally a court, like a commissioner's court that convenes and they look at all the cases for today and they look at all the responses, which would be, I was the defendant in the case, and they look at the responses and they make a ruling and they say, okay, well, yeah, pizza.com, that should belong to, or pizzahut.com, for example, or domino's.com. That should belong to the Domino's Pizza Company, not some guy from Indiana that decided it would be cute to register that name and try to get $7 million from them. I would have had to have given up that name and lost all the money that I paid for that name because, and here's how WIPO has power. They got all the registrars. By the way, that term registrar, you need to know. A registrar is any organization that hands out domain names. There are registrars in every country, not every country, but in most countries. There are some that exist in countries that give services to smaller countries. Like, anybody ever heard of a .tv extension? That's the country of Tuvalu, which is a tiny little island country, but they don't have a registrar, but they use an American company to sell their domain names for $300 a year. Very expensive. So WIPO got all the registrars in the world to agree to whatever they say. And all the registrars happily did that because before then, when there were not very many registrars in the world, there was like Network Solutions and GoDaddy, and that was kind of pretty much it. They did not want to be dealing with domain name disputes. First of all, they're not allowed to. Or they'd have to pay lawyers a lot of money to mitigate these cases, and then they would risk getting sued by the Domino's Pizza Company, for example, if they made the wrong choice. So they said, look, we need to help come up with an organization that's global organization who will handle domain name disputes. This is the only global organization that I know of. Now, within a country, if one company wants to sue another company, you know, Domino's and Pizza Hut want to sue each other over pizza.com, that's fine. They can go to local court. But if it's two different companies in two different countries, they have to go to a global entity. And as far as I know, like I said, WIPO is the only one because they got all the registrars, all the GoDaddies and all the Enoms and all the Network Solutions and all the Amazon.coms or anybody else that sells domain names, Namecheap.com, Hover.com. I use Namecheap.com because they are literally the cheapest on the planet, like $9 a month for a domain name. To agree, whatever WIPO says, that's what, yeah, you use them too because they're cheap. I think they're up to $11 a month now, which is still pretty cheap, a year, $11 a year. They all agree. Whatever WIPO says goes. So you see how that's powerful? If every registrar in the world agrees, whatever WIPO does, whatever WIPO tells us to do, you bought Cougs.org, dude, that's pretty good. Did you sell it for $8 million? I sold a domain. I used to have AMS.com. I sold that domain name because I had a company called AdvancedMedicalSystems.com, AMS.com. I sold that domain name for $70,000. And I thought, ooh, that's cool. So I registered about 80 more domain names. I sold one more domain name for $40,000, which basically bought a nice car and a nice house, or down payment on a nice car and a nice house. And then I went out and registered about 80 more cool domain names, and then I've never sold another domain since. I guess because they're either not any good or we got a much more of everything else is in the world. But anyway, I'm going to go ahead and stop here. Just make sure you go Google for WIPO and know who WIPO is and understand why they are the most powerful organization that you've never heard of in the world. And that's because the world runs on, at least the internet runs on domain names. And even though we've got a whole bunch of new top level domains like .info and .xxx and .wtf, nobody uses those because it is still a .com world. It's a .com business world. If your business doesn't have a .com, then you're not considered a very prestigious business. If Amazon.com was Amazon.biz or Amazon.us, nobody would probably take them seriously. So luckily, Jeff Bezos registered Amazon.com before he even had any idea what the hell he was going to do. He just said, well, I like that name. I'm going to register it. Eventually, I'll use it. Do you know what Amazon.com originally did? They sold books online. That's all they did. You know how long it took them to start making money? They were losing money. They were losing billions of dollars for 5 years before they ever got profitable. Now Amazon.com is literally the largest internet company, or the next to Google. Google and Amazon.com are the two biggest in the world of .com companies. And that's because they've kind of taken over. But so if you're thinking about registering some really cool domain names now, it's too late. But even if you do, if you're not using it, and that's why I had to throw this up here, by the way. That's why there is a Collins.com. I said, Colin, you need to make a web page real quick or we're going to lose this domain name. No, I don't have time for that, Dad. I don't really care. So I did. This is kind of like a little WordPress site. I literally just manually hammered this out in about 15 minutes. Just so that when the WIPO went and looked at that case, hey, are you using your website? They go to Collins.com or Collins.net or Collins.org, and they see, oh, okay, well, yeah, it's a usable website. They can send an email to me. They can send a message to me. It's got my phone number on it somewhere. They can communicate with me. And I'm not disparaging. I'm not saying Arrow Glue in Turkey is a piece of shit company. I'm not saying anything like that. So I won that case. But if I hadn't done that, I probably would have lost the case. So I'm going to go ahead and stop here because it's almost 4. I talked way too long. But interesting stuff, I think. There's a lot more to the internet than just this chapter. Make sure you go through and Google what each one of these organizations does. There will be questions on test 3 about what each one of these organizations is responsible for, who is allowed to be a member, because some of these are individuals can be members of them. Others are, you have to be an internet provider to be a member of them, or you have to be a government to be a member of them. And that's pretty much it for the chapter 10. There's a couple of other things in it, like we talk about the National Science Foundation and what Internet 2 is. But I'll talk about that at the front end of the next class on Monday. So exam 2, that's what you should be concentrating on right now, finishing your subnetting assignment, getting exam 2 done before, I think I put Saturday at midnight on there. Somebody can back me up on that. There is a little networking history assignment, by the way, that I need to change the date on because it's not submittable right now. So I'll fix that. And I'll see you guys on Monday. If you have any questions about anything before you start taking exam 2, make sure you email me, jake@uh.edu. Any questions now? Yeah, it's still due. It's just not due right now because it's broken, basically. I need to go fix it. But it's a very easy assignment. It's basically go watch this video and answer a couple questions. That's all it is. And it's just going to help you for exam 2 if you want to do it. So even if you can't submit it, go do the little assignment, because there's going to be a question on exam 2 that speaks to something that happens in that video. It's very obvious, but you need to watch it. Okay, I'll see you guys on Monday. Thank you.